So we've got a differential equation because we've got the derivative of y with respect to x defined in the equation. This is a separable differential equation because you can multiply that dx to both sides. And now you have just things in terms of y on the left, things in terms of x on the right. And so we can take an antiderivative of both sides. This is an antiderivative of 1 with respect to y, so that's going to be y. And the antiderivative over here is going to be 3 sine of x. And then there's some constant c after each indefinite integral. Whenever you take an integral, whenever you find an integral but there's no limits of integration, there's an arbitrary constant. And I'm specifying that they're two different arbitrary constants just to be really particular. But in the end, what you're going to do is you're going to subtract that c sub 1 from both sides. And if you have any old integer subtracted by some other any old integer, it's just going to make a new plain old integer, right? A new arbitrary constant. So we've got 3 sine of x plus c here. Okay, but we can solve for c because of the information they gave us. They told us y equals 1 when x equals 0. So plug in 1 in for y and plug in 0 in for x. And then if you solve this, the sine of 0 is 0, right? Because sine represents the y coordinates in the unit circle. Remember, whatever's in the parentheses is an angle measurement. So 0 degrees, this is the terminal side right here. And sine is the y coordinate on the unit circle. This point is 1 comma 0 because the unit circle has a radius of 1, right? So the cosine of 0 would be 1. Sine of 0 is 0. So 3 times 0 makes 0. Now we know what our arbitrary constant is. So the full solution here is 3 sine x plus 1.